Hi everyone, this is Anurag. Today in this session we are going to discuss about memory tuning. So first of all, let us see what is meant by memory tuning. What is the need for tuning the memory? Okay. So our Oracle database. Okay. Oracle stores data, information or data in two locations. One is memory and other thing is disk. Okay. Next, so if you want to access the information present in these locations, okay, if you want to access the information from memory, it is faster. Quickly we can access the data from the memory when compared to disk. Okay, retrieving data from the disk is a time taking process. It includes so much IO. So I'll open one more page. Here this is physical data file and this is our SGA in that database buffer cache. This is log buffer cache, shared pool, library cache and data dictionary cache. This is also some memory cache. This is also some keep cache or something like that. This is also some memory cache. So Oracle can store the information in this memory structure, that is memory cache, or it can store in data file. Whenever you want to perform any operation related to the data in the database, that data should be taken from this cache to here, or it should be taken from data file to DBBC. After that it should be placed back to, after the completion of operation, after the completion of this operation, the data will be placed back to the data file. Okay, this taking the data from data file and keeping in DBBC, after the completion of operation bringing back the data to data file, this is called as physical IO. Okay, and moving the data from memory cache to DBBC and DB cache to memory is called as logical IO. Okay, physical IO is more expensive when compared to logical IO. Okay, so if we perform so many input output operations, okay, if physical IO is increased, obviously burden on this database increases. Okay, as a result performance of the database will be decreased. Okay, why? Because whenever you want to perform physical IO, so many resources, CPU time, etc., so many resources will be used. Okay, so many resources will be used. As a result, due to this too much physical IO, our performance decreases. So we need to perform memory management techniques so as to improve the performance. So what are those memory management techniques? Let us see. So memory management. So what this memory management will do, it will maintain sizes for memory, optimal sizes for memory depending upon the database requirement. There are two types, there are two memory structures, SGA and PGA. SGA stands for System Global Area, whereas PGA stands for Program Global Area. Memory management in the sense, memory of both SGA and PGA should be effectively managed such that then on the system burden on the database decreases. So how this memory management is performed, let us see. There are two ways how memory management can be performed. So memory management can be done in two methods. That one is automatic memory management and other thing is manual memory management. Okay, by default automatic memory management will be enabled. Okay, that is, we can perform the memory management automatically or manually. Manually in the sense, DB manually is different. Automatic in the sense automatically memory management will be performed. This is the by default way. If automatic memory management is disabled, then manual memory management will be enabled. In manual memory management, again automatic shared memory management will be there, and manual shared memory management will be enabled. Okay, again when automatic memory management is disabled, then automatic shared memory management will be enabled. Okay, in automatic shared memory management also, again automatic PGA management will be there, and manual PGA management will be there. Again in manual shared memory management also, automatic PGA management will be there, and manual PGA management will be there. Okay, by default mode is automatic memory management. What happens in automatic memory management? Let us see. Okay, automatic memory management. Automatic memory management, in that two parameters are there, memory underscore target, two initialization parameters, and memory max target. We can set the values for this memory target and memory max target. What is this parameters? Later we need to set the size for the complete memory target. Okay, so that memory will be distributed between SGA and PGA upon the database requirement. Okay, according to the conditions, if need for SGA is more, then memory can be distributed to SGA more and PGA less, like that. So you can configure this automatic memory management by using these parameters, where the memory, instance memory, that is SGA, and instance PGA memory can be managed automatically by the Oracle. Okay, next, if this automatic memory management is disabled, then automatic shared memory management will be enabled. Automatic shared memory management will be enabled. So when automatic memory management is enabled, then we can use memory advisor. Okay, similarly, when automatic shared memory management is enabled, then we can use SGA size advisor. Okay, these are the advisors, they will automate the process. Okay, so in automatic shared memory management, it deals with only SGA. Previously in automatic memory management, the memory will be distributed between SGA and PGA, whereas in automatic shared memory management, within the SGA, dynamically sizes for SGA will be changed. That means in SGA what will be there? Large pool, shared pool, Java pool, like this different memory structures will be present in SGA. Okay, between these memory structures, dynamically the size will be changed when we change it automatically when we enable automatic shared memory management. So for example, there is database buffer cache and data dictionary cache in our, anyhow this will be there in our SGA. Okay, these are the memory structures in SGA. So we have assigned previously 1 GB for example 1 GB for DBBC and 1 GB for data dictionary cache. Okay, so when we are performing our operations, the data in the database will be taken to SGA. Okay, the metadata can be stored in data dictionary cache and actual data will be stored in database buffer cache for operations. Okay, think that in data dictionary cache only is half GB is getting utilized and half GB is free. Whereas in database buffer cache 1 GB is not sufficient. Okay, 1 GB is not sufficient to store all the data. Then what happens if we enable ASMM? Automatically it will change the sizes, it will dynamically change the sizes of these memory components, such that 1.5 GB is given for database buffer cache and 0.5 GB is given for data dictionary cache. Anyhow it is using half GB only, so it won't affect the performance in data dictionary cache. For database buffer cache, in turn 0.5, that is half GB, is added to database buffer cache, so that performance of the database buffer cache increases. Understood the concept? Like this performance can be improved when we use ASMM. When automatic memory management is disabled, ASMM will be enabled. If ASMM is also disabled, then manual shared memory management will be enabled. What happens in this manual shared memory management? Sizes of individual components of SGA will be managed manually but not automatically. Okay, in ASMM we can use several parameters such as SGA underscore target. Okay, this is a initialization parameter. We can have several views such as $SGA, $SGA stats, $SGA target, advice, etc. Like this we can have several views in SGA. So in this memory tuning, what we are going to see? We are going to see about keep cache, we are going to see about result cache, we are going to see about recycle cache, and also we are going to see about PGA. What is PGA? Program global area. For every server process and background process, for every server process and for every background process, separate PGA will be given. PGA is not shared, whereas SGA is shared, whereas PGA is not a shared memory structure. Okay, for every server process and for every background process, separate PGA will be assigned. Okay, the combination of all the PGAs of all the background process and server process is collectively called as PGA aggregate. 1 minute. Target. Okay, by using this parameter we can say this is PGA underscore aggregate underscore target, the combination of all the PGAs of all the processes in a database. Okay, so we will see what is recycle keep cache, result cache and recycle cache. Okay, first one, keep cache. So this is our data file. Okay, this is our SGA. In that database buffer cache, log buffer cache, shared pool, library cache, data dictionary cache. So suppose there is a table called as employee table here. This employee table is very much used table. This table should be moved to SGA whenever we want to perform any operation in this employee table. It should be moved to database buffer cache. After the completion of operation, it should be moved back to employee table. Again, if it is used, again it should be taken back, again it should be returned back after completion of operation. Like this, frequently it is getting called to SGA, frequently after completion of operation we are sending back it to data file. This increases physical IO. So to eradicate this problem, what we can do is we can add something called keep cache. What is keep cache? Let us see. So we will add something called keep cache to our SGA such that the frequently used table can be stored in keep cache. Whenever we want to perform any operation to this employee table, it will be moved to database buffer cache. After that, it will be moved back to keep cache. This is keep cache to store frequently used tables. There is one more thing called as result cache. 1 minute. What is result cache? Suppose suppose there is a certain, to perform a certain database operation, we need to perform certain calculation. This calculation of the data will take lot of amount of time. Okay, suppose we need to perform some calculation. After calculating, we will get some value. That value we will use for particular time. After the completion of operation, the table will be stored back to the data file. Then it should be again taken back whenever it is required. Again we need to perform this big operation calculation. So again it consumes resource, again it consumes time. So to eradicate that problem, we will add something called as result cache to our SGA. What happens in this result cache? The result generator, the frequently used result, can be stored in this result cache, so that whenever you want this result, you can directly get back from the result cache. No need to perform the calculations again and again, which reduces the usage of resources, burden on the resources. Okay, this is result cache. Then there is something called as recycle cache. What is recycle cache? Let us see. So for example, this is our SGA and this is our data file. Suppose here some employee table is there. This employee table is a very much important table, okay, but it is huge in size. A very big table is there, employee table. Whenever you want to perform some operation to this employee table, it should be taken back here. After completion of operation, we should we will store back in the data file. This employee table is not a frequently used table, but it is a very large table. Once upon a time we will use this table. So what happens here is, instead of taking the table here and storing back into the data file after completion of operation, we will add something called as recycle cache. What happens in this recycle cache? Let us see. In this recycle cache, the table which is very large in size will be stored in this recycle cache. Whenever we want to perform any operation related to this recycle cache, related to this table, it will be restored from the recycle bin. After the recycle cache, after the completion of operation, it will be stored back into the recycle cache. Okay, this is the concept behind recycle cache. Okay, so let us see the demo session for this memory tuning now. So let us see the demo session now. First, switch user to Oracle. Here I have created a database called work. 1 minute. Or I have created a database called as DBA. So connect to this database, SQL plus /SSDBA to connect to this database. Now give the command startup. So the database is started. So first we are going to see demo session on keep cache. So what is keep cache? Everything we are going to see now. Okay. So I have started the database. Database is open. Now clear the screen. Connect U1 by U1. Okay. Select star from tab. So what it is showing? Employee table is present. Okay. So there is a view called user. Since this is a normal user, user underscore tables. From this view, user underscore tables, we can get this information. Okay. So what I will do here, select table name comma buffer pool from user underscore tables. So what it is showing? Our employee table is present in default buffer pool. Okay, it is not present in keep cache or anything. So what I want to do, I want to move this employee table to keep cache. How to move? How to change? That we are going to see now. Okay, remember one thing, physical IOs are very much expensive, which reduces the performance very much. Logical IO is inexpensive. But due to the usage of logical IO, our performance will be improved. So instead of keeping this table, instead of taking back the table from data file, storing in database buffer cache, after the completion of operation bringing back to data file, instead of this I will create a keep cache in our memories, in our SGA, and we will store this employee table in that keep cache. How to do that? Let us see. First of all, I will clear the screen, connect to sys user, show parameter db underscore keep underscore cache underscore size. So what it is showing? Keep cache size is 0. Okay, show parameter sp file to check whether our database is running on p file or sp file. Here it is showing the location and name of sp file. That means our database is running on sp file. So I will change the value, alter system set db underscore keep underscore cache underscore size equals to 100 MB. So I have changed the size. Now show parameter db underscore keep underscore cache underscore size. Our size is approximately 112 MB. Okay, it is making the round figure. Okay, so now I will clear the screen, connect to u1 user, select table name comma buffer full from user underscore table. Now our employee table is in default buffer cache. Now alter table emp storage buffer pool to keep. That means by using this command, what we are doing, we are moving the table storage from buffer pool to keep cache. Now give the same command again, select table name comma buffer pool from user underscore tables. Now you see our employee table is in keep cache. It is moved from default buffer cache to keep cache. Like this is a demo session on keep cache. Now we will see the demo session on recycle cache, that is moving a big sized table into a default, moving a big table to a recycle cache. So for that purpose I will create one more table, create table emp1, will take with a different name, counts as select star from employee. Okay, I have created now a table. Now select table name comma buffer pool from user underscore tables. So what it is showing, our accounts table is in default buffer pool. So we want to move this to recycle cache. How to move? Let us see. First of all, connect to sys user, show parameter db underscore recycle underscore cache underscore size. What it is showing, size is 0. Now alter system set db underscore recycle underscore cache underscore size equals to some 50 MB. Okay, now show parameter db underscore recycle underscore cache underscore size equals size. What it is showing, approximately it is making it round figure. It won't take exactly what we give, it will take the nearest value. Okay, nearest value for 50 is 64. Okay, according to this condition. Okay, I will clear the screen, connect u1 by u1, select table name comma buffer pool from user underscore tables. So our accounts table is in default buffer pool. How to move it to recycle cache? Let us see. For that, alter table accounts storage buffer pool comma recycle. Like this we can move. Now check whether it is moved to recycle cache or not. Like this, our accounts table is moved to recycle cache. Clear the screen. So let us see the demo session for result cache. Okay, for that purpose, first of all, give the command alter system set result underscore cache underscore max underscore size equals to, I am giving some size 10 MB. Okay, 1 minute. The thing is, I have given quotation alter system set result underscore cache underscore max underscore size equals to 10 MB. 1 minute. Connect slash as sysdba. I will clear the screen, or I will write alter system set result underscore cache underscore max underscore size equals to 10 MB. So I am assigning 10 MB for our result cache size. Okay, next, alter system flush buffer pool. Okay, we are flushing the buffer pool, in the sense DBBC we are flushing. Okay, we are flushing out, buffer cache. Okay, we are flushing out the buffer cache. Then flush out the shared pool. Alter system flush shared underscore pool. Alter system flush shared underscore pool. Then grant plus trace. This is a role. Okay, grant plus trace to a user called Scott. There is a user called Scott. For this user we are assigning the role, we are granting the role plus trace. So grant plus trace to Scott. When we assign this role to Scott user, then from we can enable auto trace. When we enable auto trace on, we can see the execution plan and statistics so as to improve the performance. Okay, so connect to Scott user, his password is tiger. Okay, select star from tab. So these many tables are there. I will clear the screen. Now set auto trace on. Okay, auto trace we have enabled. Now select star from EMP. So it will show the statistics and execution plan and also all the data present in that table. Now I will give set time on. Set time on. I will clear the screen here. So this is the time now. Now select, 1 minute, describe EMP. In EMP these many rows are there. Now select job comma sum of salary from EMP. So 1 minute, it is showing some error. So select sum of salary from EMP. So this is it shows aggregate of salary. It shows aggregate of all the salaries in that employee table. This is the aggregate. Now this will be stored, this result will be stored, and individual results of the salaries will be stored in our result cache. So we can, from the next time when we are accessing the data, whenever we are giving the queries, this calculations already present in result cache, they will they will be used directly. So first, for that purpose I am clearing the screen. Then connect slash as sysdba alter system set result underscore cache equals to auto. We should enable automatic result cache mode. By default it won't be auto, we should make it auto. Okay, then I will clear the screen. Connect to Scott user. Next, select, sorry, spelling mistake. Select plus result underscore cache sum of salary, comma, ename from employee table, group by ename. That means with respect to each and every employee, I want to see the salary. Okay, so the result is already stored in result cache. From that our result will be retrieved. Okay, within no span of time we will get the output. Understood the concept? This is about result cache. Okay, hope you enjoyed this session. Thanks for watching this video. Bye.